Hello everyone and welcome back. So far in IUPAC nomenclature, we have seen what is the format of IUPAC name. We have seen how to select a parent carbon chain. And in today's lecture, we are going to take up the next step, that is how to number the parent carbon chain. Basically, our entire naming process I have boiled down into simply two steps. One, select the parent carbon chain, and two, number the parent carbon chain. So let's get started with how to number the parent carbon chain. Once you have selected the parent carbon chain, you have to keep in mind this priority: primary functional group, then multiple bonds, then substituent. What it means is that once the parent carbon chain is selected, when numbering, you have to keep in mind that you assign minimum possible number to the primary functional group. Then, if there are two ways in which you are assigning the same number to the primary functional group, you will move to the next criteria, multiple bonds. You prefer that numbering in which multiple bond gets the minimum possible number. Let us check one example and try to understand this. We'll take one simple example. Say that we are given this particular carbon compound. In this, carboxylic acid is my functional group. So when selecting the parent carbon chain, we'll select the parent carbon chain like this. Once the PCC is selected, your major task is done. Now when numbering, there are only two ways. Either we can go from left to right in numbering the PCC, or we can come from right to left. There is no third possibility. There is no third possibility. There are only two possibilities. You can go from this end to the right hand side end, or you can go from right hand side to left hand side end. Only two ways are there. So which way do we prefer? We prefer that way in which the primary functional group gets the minimum possible number. For example, if I start numbering from left hand side, this carbon gets 1, 2, 3, 4, 5. So in this case, our primary functional group gets the number 5. Whereas if I go the other way around, that is I start numbering from this end, 1, 2, 3, 4, 5. In the second way of numbering, we are assigning the minimum number to the carboxylic acid, that is 1. And hence, the second way of numbering is correct, the first way of numbering is wrong. Now let us have one more example. If you look at this one, here is my parent carbon chain, here is my parent carbon chain. In which direction to number it? If I go from left to right, then the carbon attached to the functional group, which is called alpha carbon, is assigned number 3. But if I come the opposite direction, 1, 2, 3, 4, 5, the number assigned to the alpha carbon is same. That means I could number this chain either from left to right or right to left. There is absolutely no problem. However, let us place one double bond. Let us place it somewhere over here. So in this particular example, whether you go from left to right or right to left, you end up assigning the same number to the functional group. That is, both the ways the functional group gets assigned the same number, and therefore we cannot use functional group as a criteria to decide which way to number it. And therefore, in such cases, we will move to the multiple bonds. You will not move to the multiple bonds unless it is required. And it is only required if both ways the functional group gets assigned the same number, like in this one. So since both ways functional group is getting assigned the same 3 number, let us check multiple bond, in which case multiple bond gets the minimum number. When I am going from left to right, my double bond occurs on the first carbon. it is between first and second, we say that the double bond is present at position 1. Whereas if I come from right to left, it is between 4 and 5. That is, it is at the position 4. We have to assign minimum number to multiple bonds. Therefore, I would prefer giving it number 1 rather than 4. So going from left to right is the correct way of numbering this particular PCC. Let's have one more example. This one. The PCC is a simple like this. Once I have selected the PCC, again I could go from left to right, in which case I'll start numbering like this. 1. Now, there is no functional group. There is no functional group. Hence, I should jump to multiple bond criteria. I should assign minimum number to the multiple bonds. But there are 2 multiple bonds here. Here there is a double, here there is a triple bond. At this point, we don't distinguish between double or triple. For us, they are simply multiple bonds. So multiple bonds are present at position 1 and at position 3. So we say that the set of locants is 1, 3. We say that multiple bonds are present at 1, 3. If we go the other way around, then we shall start numbering them like this. That is, multiple bonds are present at 3 and at 5. Multiple bonds are present at 3 and 5. In such cases, we compare one number at a time. And at the first point of difference, we decide which one to choose. Here 1, here 3. Check the first number of this locant with first number over here. First number is 1, first number is 3. That's it. That's the first point of difference. And you select that set of locants where at the first point of difference, you get the minimum number. So out of 1 and 3, the minimum number is 1. And therefore, this is the correct way of numbering. This is the wrong way of numbering. Let's have one more example. Let us say this example. This is my PCC. There is no functional group. There are no multiple bonds. There are only substituents. In case you have any confusion, sir, halogens are functional group. As per IUPAC standards, when you are naming any organic compound, bromo, iodo, these guys are to be treated as substituents and never as a functional group. All right. So if we start numbering from left side, 1, 2, 3, 4, 5, 6. So my set of locants is 2, 3, 5. 2, 3, 5. If I go the other way around, it becomes 1, 2, 3, 4, 5, 6. So set of locants is 2, 4, 5. 2, 4, 5. So which one to select? So which one to, by the way, I have moved to substituents only because functional group and multiple bonds are not present. If they were present, then I would have checked that criteria. All right. You compare these first numbers. Sir, first numbers are same. So I cannot resolve the tie at this point. I could have resolved it here, but here it is not the case. I cannot resolve the conflict at the first point. Therefore, I should move to the second point. You will move to the second number only when the first number is tie. It is same. So in this case, the second number is 3. The second number is 4. So which is the minimum one? 3. Therefore, this is the correct way of numbering. This is the wrong way of numbering. So when numbering the PCC, remember the functional group must get the minimum number. If there are 2 ways in which your functional group is getting assigned the same number, only then will you move to the next criteria and check the multiple bonds. Let's solve some examples. I'll take some examples from our previous class in which we have already selected the PCC. तो मान के चलो ये है. This is my PCC. In case 2, this would be my PCC. Okay, we have already done it in the previous lecture. In case you have not watched that previous lecture, you could just go and have a look how to select the PCC. Coming back to this. Now, once you selected the PCC, your majority work is done, because now you have to number it, and there are only two ways of numbering. Go from left to right, one, or you go from right to left. So I will check the priority list. Sir, I have to assign, this is the priority for numbering. This is the priority for selecting, which we already spoken about in the previous lecture. So when numbering a PCC, so primary functional group must get the minimum number. So if I go from right to left, I will assign minimum number 1 to the functional group. Whereas if I had to come the other way around, I would have assigned it number 4. So that would be the wrong way of numbering it. Moving to the second one, I have to assign minimum number to this carbon. How to do that? Left to right? No, right to left. It's that simple. Likewise, here is my PCC. Sir, why did you go down here? I went down here because there is a multiple bond present. So there is a multiple bond, there is a functional group. There is a multiple bond, there is a functional group. My first point, my first job is to check that I'm assigning minimum number to the functional group. And therefore, the correct way to number this is to start from here. 1, 2, 3, 4. Likewise, over here, the right way of numbering this PCC is to assign minimum number to the carboxylic acid. 1, 2, 3, 4, 5. One point that I would like to make is that carboxylic acid has the highest priority in the functional group. And therefore, if you have one carboxylic acid in your given carbon compound, the chain numbering will always start with that carbon. If there is one carboxylic acid, only one COOH group, like in all these 4 examples, then the numbering will start from COOH always. Let's move to other examples. Over here, this is my PCC. There are 2 functional groups, COOH, COH, identical functional groups present twice. So if I had to go from left to right, my set of locants would be, I would have a functional group at 1 and at 4. So my set of locants is at 1 and 4. If I come the other way around, from right to left, also I would have numbered it like this. 1, 2, 3, 4. Again 1, 4. So whether you go from left to right or right to left will make no difference. Likewise, in this example, the functional group is aldehyde. The functional group is aldehyde. So I have to give minimum number to these aldehydes. So I could either go from here 1, 2, 3, 4, or I could come the other way around. I will end up assigning same numbers to the functional group. So no problem with that. Let me make a slight change to this. Let me make a slight change to this. Let me say that I had something like this. My PCC would remain the same. The PCC would remain the same. Whether I go from left to right or I go from right to left, I will end up assigning same numbers to the functional group. For example, 1, 2, 3, 4. The functional group gets the number 1 and 4. The functional group gets the number 1 and 4. And if I had to go opposite direction, that is 1, 2, 3, 4. My functional group is still at 1 and 4. My functional group is still at 1 and 4. That means the conflict cannot be resolved at the functional group level, and hence I must go to the next step, that is multiple bonds. But in this case, no multiple bond is present, and hence I will go to the next step, that is substituents. I have to see to it that I assign minimum number to the substituents. Well, let us see the green part, the green way of numbering. At second position there is methyl, at third position there is ethyl. That means the set of locants is 2, 3. In this green way of numbering, there is one substituent at 2, there is one substituent at 3. There is one at 2, there is one at 3. So the set of locants is 2, 3. And the yellow way of numbering is again at 2 there is ethyl, at 3 there is methyl. So again the set of locants is, see, 1, 2. At 2 there is ethyl, at 3 there is methyl. So we'll compare. And if you compare, you will see that there is no difference. This is also 2, 3. This is also 2, 3. There is no difference. So that means functional group cannot resolve our doubt, multiple bond cannot resolve our doubt, substituent cannot resolve our doubt. We're not arriving at a conclusion. Which way is correct? And we know that both are not the same. It is not like the sixth example. Sixth example, both the ways of numbering was same because the substituent present here, ethyl, and substituent present here, ethyl, were the same. Whereas in this case, this substituent is different. This guy's name is methyl substituent. And this guy's name is ethyl substituent. So it's not the same. Because in one way, you are saying we have methyl at second position. And in second case, you are saying we have ethyl at the second position, which is not the same. So in that case, because none of these three criteria are able to resolve our doubt, we will resort to the fourth criteria, which are not written here, that is resorting to the alphabetical order. We will assign minimum number to that substituent which is alphabetically occurring first. Alphabetically occurring first means if you had to search for these two groups in dictionary, methyl and ethyl, then which word would occur first? Ethyl, because A, B, C, D, E. E comes first, M. This name starts with methyl, M. So M would occur later in the dictionary. E would occur first. That's what we mean by alphabetical order. That word which will appear first in dictionary, okay, is given higher preference. So between methyl and ethyl, alphabetically ethyl would occur first, and therefore we will prefer to give minimum locant, minimum number to ethyl substituent. That is, we would prefer giving number 2 to ethyl, and therefore this is the correct way of numbering. But sir, why did we go to the alphabetical order? Only because the problem could not be resolved over here, and that's why we went to the alphabetical order. If the set of locants were different, we wouldn't have resorted to the alphabetical order for resolving our difficulty. Fine. Moving to the next example, this one. Here we have a PCC. Again, this example was done in our previous class. We have to give minimum number to the functional group. That's what we start with, sir. We have a functional group OH over here, and this is my alpha carbon. I have to assign minimum number to alpha carbon. Let us say, again, I could go either from left to right or right to left. Going from left to right, 1, 2, 3, 4, 5. Therefore, at the third position, alcohol is present. If I come the other way around, 1, 2, 3, 4, 5. Sir, again at third position there is OH. That means functional group cannot resolve our difficulty, and hence we must go to the next criteria, that is multiple bond. We have to prefer that numbering in which multiple bond gets assigned the minimum number. In this green way, it is 3. Double bond is appearing between 3 and 4. So we say that the double bond is present at locant, that is number 3. And in this yellow way of numbering, we say that double bond is present at 2 So we will prefer this way, because in this case we are assigning minimum number to the multiple bond. But why did we ask about that? Why did we go to the multiple bond? Because functional group was getting the same number, either from left to right or from right to left. Fine. You can try this yourself. This is quite simple. There is no functional group, sir. Therefore, I must check multiple bonds. Sir, if I go from left to right, at the second position there is a double bond. At the fifth position there is a double bond. Acha. There is a double bond at second position and at fifth position. If I go in the opposite direction, so 1, 2, 3, 4, 5, 6, 7. Double bond occurs at 2 and at 5. So both ways the set of locants we are getting 2, 5 is same, and hence I must resort to the next level, that is substituents. But there are no substituents, and hence we say that both way of numbering is same because there are no substituents. Either way, at second position double bond, fifth position double bond. Other way around, second position, fifth position double bond. So no issue with that. Let us do example number 11. Example number 11. Sir, there is no functional group, hence multiple bonds. If I go from left to right, 1, at second position there is a multiple bond, at fourth position there is a multiple bond. Set of locants are 2, 4. If I go opposite direction, 1, 2, 3, 4, 5. So there is a multiple bond at 1 and multiple bond at 3. 1, 3. Which one would you choose? 2, 4, 1, 3. Check karo. Compare 1 with 2. Sir, this is the minimum number. Hence, this is the correct way of numbering. This is the wrong way of numbering. Come to this one, 10th one. Come to this one, 10th one. This is my PCC. I'll go from left to right. 1, 2, 3, 4, 5. The set of locants. At first position there is a multiple bond. At fourth position there is a multiple bond. 1, 4. If I come in the opposite direction, 1, 2, 3, 4, 5. So at first position and at fourth position. First position and at fourth position. So the set of locants is same. Sir, 1, 1, 4, 4. So we cannot resolve. In that case, what to do? Sir, in that case, you move to the substituents. But sir, there are no substituents. So a bit tension ho gaya. Since there are no substituents, what to do? So both ways are correct. Both ways cannot be correct. See, to start with, we do not distinguish between a double or a triple bond. For us, they are simply multiple bonds to start with. But now we have arrived at a point where the set of locants are same. And also there are no substituents to resolve. And we cannot say that both ways are right, because in case 1, first position there is a double bond, fourth position there is a triple bond. But other way, at first position there is a triple bond and at fourth position there is a double bond. So there is a difference between saying that double bond is at first position or triple bond is at first position. In such cases, again, we will check this first. That is set of locants. Set of locants are different than here you have your answer. First come, first serve. Whoever comes first will be chosen. But here, the set of locants is same. So I will prefer that way in which double bond gets the minimum number. That is, we prefer double bond over triple bond. Why, sir? Because double bond is in and triple bond is ein. Alphabetically, in will come before ein. So we will assign or we will choose that way in which in, since it appears alphabetically first, we will prefer that way in which in gets minimum number. In gets 1 number here, in gets 4 number over here. This is wrong, this is right. All right. Check out this one. Whether to go from left to right or right to left. Sir, 1 at first position, 2, 3, 4, 5, 6. Multiple bonds are present at position 1 and at position 5. Fine. And if you go the other way around, the opposite direction, 1, 5, 6. Again 1, 5. So since the multiple bonds, the locants are same, we cannot resolve the doubt over here. We shall move to the next level, that is substituents. When I go from left to right, the substituent is present at third position. And if I go from right to left, substituent is present at fourth position. So substituent is present at third, substituent is present at fourth. So I will prefer third over fourth. So I will number from left to right. I could not do that substituent business over here because there were no substituents. And hence, I had to go with alphabetical order. Fine. Let us check this one. This is my PCC. This is my PCC. So, if I start numbering from left to right, 1, 2, 3, 4, 5, 6, 7. Set of locants. See here. Sir, functional group not present. Sir, multiple bond not present. Therefore, I shall check substituent. At second position and at fifth position. At second position and at fifth position. If I go in the opposite direction, how do I do that? 1, 2, 3, 4, 5, 6, 7. So my substituents are present at 3 and at 6. Substituents are present at 3 and at 6. I will prefer 2, 5 over 3, 6. Therefore, this way of numbering is wrong and the green way of numbering is right. Let us try to resolve this one. Again, as I told you, there are only two ways of numbering. One is from left to right and other is from right to left. So in left to right, I have locant at position 2. There is this methyl group at 3, at 4. At 2, at 3, and at 4. Whereas in the other case, I have 1, 2, 3, 4, 5, 6. So which one will you choose? Sir, compare 2 with 4. Here only my conflict gets resolved. So green way of numbering is right. Yellow way of numbering is wrong. You can solve this yourself. Let us move to example 16. 15th one is quite simple, so I'll go to example 16. PCC. My PCC is this one. Sir, there is a functional group, therefore like this, okay? Like this. By the way, in last class, I told you, if to PCC, CHO is connected as a substituent, then this guy is called formyl substituent. Okay. But if in PCC, CHO is there included, then this substituent is called oxo. For example, in my PCC, CHO's carbon is included. Therefore, this substituent is called oxo substituent. Whereas, if I have to select this particular carbon chain over here, then this CHO is left out. So CHO could be a part of PCC or it could be outside PCC. If CHO is outside PCC, the name of this substituent would be formyl. Whereas if CHO is included in PCC, the name of this substituent would be oxo. Anyways, let's proceed. How to number? Sir, there are only two ways, sir, to number. Either you go from COOH to CHO or from CHO to COH. Check the criteria. Functional group. This is your primary functional group. Therefore, you have to assign it minimum number. And hence, this is the correct way of numbering the parent carbon chain. By the way, which are the substituent? At third position, you have methyl. At third position, you have ethyl. Fourth position, you have methyl. And at fifth position, you have oxo. All right. हाँ भाई, check करो. ये बहुत ही आसान. This is the PCC. I told you last time cyanide. Cyanide is a very egoist fellow. Either cyanide is a primary functional group. If not primary functional group, you leave it outside the PCC. What did I say? Cyanide is either your primary functional group. And if it is not, then you leave it outside PCC. Fine. How to number? Quite simple. You assign minimum number to the functional group. And I told you also, if only one COOH is present, start numbering from that number. Okay, carbon. Is there only one COH? Yes, sir. Start numbering from there. बहुत ही आसान. Let us check this one. This one. Here, this functional group is called amide. So when we are going to select the PCC, we are going to select amide and we are going to turn left because there is a double bond. So how to number it? Well, either I could number from left to right, in which case I will assign 5 number to the functional group. Another way is to go from right to left and assign 1 number to the functional group. Obviously, we are going to assign 1 number to the functional group. This functional group is called amide functional group. Amide functional group. And at which position is double bond present? At third position. At which position is substituent propyl present? Sir, at second position. All right. Let us look at this guy. Let us start it from scratch. We'll select the PCC. In PCC, my job is to see to it that carbon attached to functional group is included. So ये तो ऐसा हो गया. Now if I go on top, I will encounter 2 carbons. If I go down, I will encounter 2 carbons. It makes no difference for me. It is going to be one and the same thing. How to number, sir? Well, quite simple. You could either number from left to right or right to left. I'll number from left to right because in that way I will assign 2 number to carbon, functional group carbon. If I come the other way around, then I end up assigning 5 number to it. 2 number is smaller than 5. Very good. Baat khatam. हाँ भाई, look at this one. We already done this type of examples. This is your PCC. This is your PCC. Well, this is your PCC. और कुछ है ही नहीं. उसमें क्या करना? So if I come from left to right, if I come from, again I'm repeating this, 1, 4. So the set of locant, multiple bond present at 1, multiple bond present at 4. If I go other way, 1, 2, 3, 4, 5. Multiple bond at 1, multiple bond at 4. Set of locants is same, sir. Set of locants is same, sir. But even though the set of locants is same, in one case you are saying double bond at 1. In case 2 you are saying triple bond at 1. So you cannot say, sir, kuch bhi karenge. Either way, sir, it is same. No. Either way it is not same. Either way it is not same. Why? Because in one case double bond is at first position, in other case triple bonded at first position. In such cases, what to do? Set of locants is same, and therefore we are going to prefer in over ein alphabetically. So this is the correct way of numbering, this is the wrong way. So I'll go from 1, 2, 3, 4, 5 like that, and not the other way. Yahan pe, if I come from left to right, my set of locants is 2, 4. If I go from right to left, 1, my set of locants is 1, 3. Obviously, I will prefer 1, 3 over 2, 4. So this is the correct way of numbering, this is the wrong way of numbering. My point is that for us, multiple bond is multiple bond to start with. We do not distinguish double and triple. For us, simply multiple bond. Only when you see that the set of locants are same, will you start to distinguish. Oh, okay, this is double, this is triple, this is in, this is ein, and therefore I have to give minimum number to in, then ein. This one, now it's quite simple for you. Sir, double bond occurs first. Set of locant is 1, 3. Opposite way, it is 2, 4. So 1, 3 will be preferred. Let us move to example number 24. The PCC, this one is the PCC. So all these are simple ones. The PCC is quite simple. First priority is to be given to the functional group, but there are no functional groups. Sir, there is one functional group, bromine, bromo. No. Halogens are not functional group in IUPAC naming. They are substituents. They are prefixes. So bromine, chlorine, bromine, iodine, they are not functional group. They are substituents. They are at the same level as methyl, ethyl, and so on. There is no difference. So methyl, ethyl, bromo, chloro, iodo, these are substituents, always substituents. They are not functional group. Point 1, there is no functional group. Point 2, there is no multiple bond. So I must choose the numbering based on the substituents, that is based on the locants. Going from left to right, my set of locant is 2, 3, and coming from right to left also, my set of locants will be 2, 3. So both ways, sir, 2, 3, bas. This way also 2, 3, opposite way also 2, 3. So what to do? We cannot resolve the doubt. So we will say, sir, this guy is bromo and this guy is methyl. They are not the same. And therefore, we have to assign minimum number to that substituent which occurs alphabetically, say, alphabetically above B. B comes before M. I told you, alphabetically higher means that word which would appear first in a dictionary is given preference. So of course, bromo starts with B, which comes before M, methyl, and hence bromo should get the minimum number 2. Therefore, this green way of numbering is correct, yellow way of numbering is wrong. That is, you will start numbering from left side, 1, 2. You will give 2 number to bromo, not 2 number to methyl. On similar grounds, can I say that this is the correct way of numbering? Because both ways, the set of locants is 2, 3 only. Again, I am resorting to alphabetical order only because the set of locants is same in both the direction. Bromo must be given higher precedence than chloro. Bromo must be given lower number. Higher precedence means lower number than chloro. Yeah, sir. Check here. If I go from left to right, 1, 2, 3, 4, 5, 6, 7. Set of locant, 5 and 2. If I come the opposite way, yellow way, third position there is a locant, 6th position there is a locant. Green way of numbering, there is 1 at 2, 1 at 5. Obviously 2 and 3 you compare, this is better. This is the correct way of numbering, this is the wrong way of numbering. Sir, why? Sir, this is ethyl, this is sir ethyl, and sir this is methyl. So you should have given minimum number to ethyl. No, that's wrong. I should have given minimum number to ethyl only if the set of locants were same. So my first focus is going to be set of locants, and only when the set of locants is same in both the direction will I check the alphabetical order. By default, I don't start with the alphabetical order. Fine. Just last one more example. Yeah. Sir, which way to start? Let us check. There are only two ways, sir, to number it. Second position bromo, 4 iodo, 5 chloro. Second position, 4 position, 5 position. If I go in the opposite direction, 1, 2, 3, 4, 5, 6. There is 1 at 2, there is 1 substituent at 3, 1 at 5. 1 at 2, 1 at 3, 1 at 5. 2, 2, same. Therefore, I must move to the next number. 4, 3. Well, 3 is the smaller number. Therefore, yellow way is correct, green way is wrong. So, in today's lecture, we have seen how to number the parent carbon chain. Once these two steps are done, that is, once you have selected the PCC and then numbered it, your 99% job is done. Now naming this compound is extremely simple. All we have to do is what we learned in the first lecture, the format. We have to put the words in its proper place. For example, I'll give one example. Okay. Here the PCC has how many? 1, 2, 3, 4, 5, 6 carbons. Since PCC has 6 carbons, your root word would become hex. Since all these guys are single bonded, your primary suffix would become ane. Single bonds, ane, alkene. Double bond, alkene, like that. The primary prefix is not present because primary prefix, as I told you in lecture 1, is cyclo, bicyclo, like that. So it's not there. The secondary prefix contains all the substituents. How many substituents are there, sir? 3, sir. Bromo, iodo, chloro, along with the numbers. So we'll say at second position there is chloro, at third position there is iodo, and at fifth position there is bromo. So this guy, bromo, alphabetically comes before chloro and then iodo. So when writing the secondary prefix, you have to write the prefixes along with the locants. For example, when I will write bromo, I will not simply write bromo. I will say bromo is present at 5th position, therefore 5 bromo, 2 chloro, 3 iodo. So it would become like this: 5 bromo, then 2 chloro, then 3 iodo. Why this order? Alphabetical. B comes before C, C comes before I. So the full name would be 5 bromo, 2 chloro, 3 iodo, hexane. In our next class, we will learn more examples as to how to finally write the name. Basically, I have broken the entire this complex rules into simple 2 rules: selecting the PCC, numbering the PCC. Bas, there are only 2 rules, and in those 2 rules you have to just remember the criteria, that is you have to remember the priority. So once you have done these 2 steps, then your name is ready. So how to put those different parts, prefix, root, suffix together, that we will see in our next lecture. Thank you so much.